Hello. In this video, we're going to take a look at two examples of finding areas between two curves. So the first example is finding the area of the finite region bounded by y equals the square root of x and y equals 1/4 x. So taking a look at those graphs, we have that the square root function looks like this. So here is y equals the square root of x, and our linear function, that y equals 1/4 x, is a line going like so. So y equals 1/4 x. So we want to find this area. First thing is that we're not given the start and end of this integral. So we need to find that. Finding these 2 points would be finding the intersection points. So first things first, find the intersection points. So when does the square root of x equal 1/4 x? First, I'm going to get rid of this fraction by multiplying both sides by 4 to get 4 square root of x equals x. And then getting rid of this square root means squaring both sides to get 16x equals x squared. And then moving everything to one side gives us 0 equal to x squared minus 16x. And we can factor out an x. 0 equals x times x minus 16. The two x coordinates are x equals 0 and x equals a positive 16. This leaves us with the y coordinates. When x is 0, we have the square root of 0. So y equals 0. And when x is 16, we have the square root of 16. So y is 4. So we have the 2.00, which we could easily see from our graphs is one of the intersection points. And we have 16,4 as the other intersection point. Now, we actually want to set up our integral to find the area. And the area between two curves, between 2 points, x equals a and x equals b, is going to be the upper function in terms of x minus the lower function in terms of x. So we are looking at the integral between the x coordinates 0 and 16. So 0 to 16 of the upper function. Everywhere from 0 to 16, square root of x is larger, minus the lower function, which is 1/4 x everywhere. So the integral of the square root x minus 1/4 x dx will solve the problem of what the finite region is. And then third, we solve. This integral is also the integral 0 to 16 of x to the 1/2 minus 1/4 x dx. And using the power rule on each of those, we add 1 to our power to have 3/2 and then divide by that power or multiply by the reciprocal, minus 1/4, add 1 to the power and then multiply by the reciprocal of the new power to give us 2/3 x to the 3/2 minus 1/8 x squared on the interval 0 to 16. Plugging in 16 and 0, we get 2/3, 16 to the 3/2, minus 1/8, 16 squared, minus 2/3, 0 to the 3/2, minus 1/8, 0 squared. This whole piece here is just 0. And then working out this two pieces, we get 2/3 times 64 minus 32, which is a 1/28 minus 96, and 28 minus 96 gives us 32 thirds as our final area between those two curves, square root x and 1/4 x. The second example, find the area enclosed by the curves y equals e to the x and y equals x squared minus 1 between x equals 1 and x equals -1. We want to look at those graphs. Our first graph is e to the x, which looks like this. And our second graph is x squared minus 1, which is the parabola opening upward with a y-intercept of -1. And we are going between x equals 1 and x equals -1. So that is those green lines sketching in here. X equals 1 and x equals -1. In the last example, the first step was to find the intersection points. But in this problem, when it comes to finding the intersection points, that is actually given to us. So we don't have any work to do there. Our intersection, or our bounds, are the x equals -1 and x equals 1. So that step is already complete. The second step is to set up our integral by figuring out where is the upper function and where is the lower function. Between -1 and 1, e to the x is always the upper function. So we have the integral e to the x minus x squared minus 1. Between -1 and 1. 3 is now solving. So we are going to take this integral, which is the integral from -1 to 1 of e to the x minus x squared plus 1, distributing that negative, dx. And the antiderivative there, we have the e to the x rule. So e to the x. Then we have two power rules. So add 1 to the power minus x cubed and divide by our new power. So 1/3 x cubed. And then the antiderivative of 1 is x. This is being evaluated from -1 to 1. So plugging in those bounds, we have e to the first minus 1/3 1 cubed plus 1 minus e to the negative 1 minus 1/3 negative 1 cubed plus negative 1. Simplifying this out, we have e minus 1/3 times 1 cubed is 1 plus 1 minus 1 over e minus negative 1/3 times negative 1 cubed. Negative 1 cubed is still negative 1. Negative 1/3 times negative 1 is a positive 1/3. So negative of a positive 1/3 is going to be minus 1/3. And then plus a negative 1. With that negative distributed, we have a plus 1. Simplifying these out, we have e minus 1 over e minus 1/3 minus 1/3. So negative 2/3 plus 2. 2 is also 6/3. So as simplified as this gets, we have e minus 1 over e plus a negative 2/3 plus 6/3, giving us 4/3, or giving us 4/3. And there is the area. We could use a calculator to give us a more precise decimal to understand what is that approximately. It's going to be close to 3, but we have our exact answer of the area enclosed by those two curves. We will look at some more examples in the next video.